Okay, hello. So welcome everyone to, I guess this is essentially I think it's like the first time I'm trying to talk about my dissertation work to like a non-academic audience. So it is about creating domain-specific data science materials for a set of learners. So first things first, UBC, where I'm currently working and living, is on the native lands of the Musqueam people. And I'm still learning about this process, but they are the native peoples around the Fraser Estuary, which is the river that is right south of where UBC is. Next is the actual land where a lot of this work was conducted, which is in Southwest Virginia in the United States. And the people that used to live there, the native peoples there, were the Tutelo people. And it's also nice because they also eventually migrated up to New York State, where I'm from. And another thing, so this deck is made using Quarto, which is essentially the next iteration of R Markdown. And if you notice that the color scheme highly matches the RLadies theme, and that is because Beatrice I know she's from South America somewhere. I think it's Brazil. She's from Brazil. Actually translated this theme over from Allison's theme that uses Sherigan. So that's why things look the way they do. And yes, a little bit about me. You can, I am a postdoc research and teaching fellow at UBC. I'm also right now a data science educator at RStudio. And there was an announcement about RStudio Academy a couple of weeks ago. So I'm essentially on that team. And I've done work and volunteer through the Carpentries and also authored this book. But you can also just find me on social things in the top left corner there, including Twitch. Someone told me to make that call out, so that's also a thing. But first, a little intro about the land of data science education. So currently, if we think about or look at data science education outside of like the boot camps and non-academic courses, they're typically run by joint departments in the master's and bachelor's programs. And if you look at the courses that they offer, they're still very heavily geared towards, your traditional computer science and statistics courses for both the bachelor's programs and the master's programs. And that sort of is a problem in the sense that because there's so much focus around computer science and statistics, which is a core component of doing data science, what ends up being left out are like courses focused around like actual data products. So like we teach all of these like technical skills, but then there's fewer emphasis or less emphasis around like, what do you do when you finish your analysis and stuff like that. And this is from a paper that was published in 2020, but this was looking at courses from 2014 and 2015. So yes, things have changed since 2014 and 2015, but it does show that like initially this was a problem and kind of still continues to be a problem where people do all this work and then they present the raw stats output as like the analysis and not like knowing how to convey the analysis that they've done. And so the thing to keep in mind is, well, the image from the top left corner here, this is I should not use my mouse. This is the image that we've probably all seen if we've opened the R for Data Science book. And you see like the import, tidy, this cycle of understanding to communicate. The image below is actually from the GAZE 2 report, and this is the essentially stats curriculum for K to 12 in the United States. And you can see that it also still has like this, have a question, collect data, analyze data. There's like a mini cycle in there, and then you interpret your results, et cetera, et cetera. But I would like to also point people to the image to the right, which sort of encompasses the two images on the left. And this was something that I sort of put together where um, after the analysis, there's this report that gets generated or should be generated, and that comes from interpreting results. And then what's really important is like you're not creating these analyses products in isolation. Like they're usually geared towards some kind of decision, right? And keeping in mind that like because they're going to be used for a decision, that decision then affects the rest of the world, and that cycle of making a decision affecting the world, which then affects your next round of data collection, is really important. And really, if you can keep that in mind, that is essentially like my thesis, my not actual thesis, but I would like to say that like that's probably where a lot of ethical problems will stem from, and you can avoid just realizing that this stuff will affect the world. And so what I've done is sort of take data science education and say like, okay, if we wanted to teach a domain specific subgroup of people, in my case, it was people who work in medicine, how would that go? And so the sort of not really a problem, but essentially like a lot of data science programs are really general. Um, they're made to try to encompass single broad audiences and not really focused on individual domains. And so that means that as an educator, you do have the opportunity to sort of branch out to what you need to do to create domain specific materials. And that means that you can better cater towards their actual needs, because like your data sources, how they're loading in data, the way they're working with data can all be catered towards their really specific use cases in term, and as well as the like modeling techniques that you would end up using as well. And so the other thing in, at least in medicine in the United States, there is also this problem where more people want opportunities to take part in all of these skills, but there actually aren't that many opportunities presented to them. So it's this notion that informatics interests outpace opportunities. And so like one way we can sort of deal with this is just make more of everything, right? So you can make things better, more relatable. You can just make more things, but also just trying to promote things so more people can find it. Is things that you can do to sort of branch out into at least the medical domain. And I suspect this is also going to be the case for a lot of other domains as well. And so one of the things that we need to combat is not really like Excel itself isn't the problem. It's mainly people sort of treat Excel worksheets as a data visualization and start doing things that you shouldn't be doing with data with Excel, because it makes it so easy because you can just click and change things on the fly. And so it's not really that, again, Excel is not really the problem, although it's stuff like, Excel renaming genes into dates, and it's easier to change science than it is to like change Excel. But it is like people are thinking about your data in the wrong way, and sort of Excel makes it easy to sort of break some good practice rules. And so the goal here is like, okay, how do we sort of show people, or at least teach people what good data practices are? And if they still want to work in Excel, it's fine. But as long as they're mindful of, those rules that they try not to break, even if they're using a graphical spreadsheet program. And so a lot of that also stems from the fact that like, yes, if you don't have any of these like fundamental understanding of good data practices, then you do end up with a whole bunch of problems. So this is sort of a list that was curated by Joel Ostblom and Tiffany Timpers at UBC, and they listed some consequences of reproducibility failures. So like in a more benign case, like, okay, a paper gets retracted, but in more serious cases, like entire RCTs are started with actual people, and they get started off of like bad data. And so those are essentially like two extremes of what happens when you don't properly work with your data. And then the other reason for why I even thought this was a good idea is stuff like R and programming languages like R are growing. And so just for one like big use case is, at least in the United States for the Food and Drug Administration, there is now like a pilot as of November of last year to formally submit like entire analyses in R. So for like drug like drug uh, like review. So, and in the case in the past, like there was like this sort of this myth that like everything had to be submitted through SAS to the FDA, which is, it was always a myth, but this is sort of like solidifying the fact that like no, you can actually use R to submit like your RCT work for drug review. So how do we go about thinking about creating a set of learning materials? And this doesn't even have to be domain specific, just I want to create something for people. There is this one workflow that you can use, and it's called a backward design. And it has these 6 steps where you identify your learners, and then once you have your learners identified, you plan out your lesson content by trying to figure out like what your learners know, and you're mapping out how to get them from where you know to what you want them to know. And the way you do that is you sort of create a end goal, also known as a summative assessment, or if you've been in school, it's like a final exam or midterm exam kind of thing. And then from the summative assessment, you work your way backwards and saying that, okay, I have this big final project. How do I break this up into smaller things that I can test? And then once you have those smaller things that you can test, then you can outline your course and trying to meet those, like essentially treat those smaller formative assessments as little milestones. And the school way of thinking about it is like formative assessments are like your homeworks, and then your homeworks build into like an exam. And then you can write a summary of the course to sort of help get that information out to other people. So the first project I worked on was really just that first step in the backwards design process of like, how do we find out who our learners are? And so the methodology that I used was something called using a persona. And it is, a persona is something that comes from the field of product design. And so it's really a way of like collecting data and then using that data to create an imaginary person. And in that process, you're essentially really formally and explicitly writing down what you think that the user will do, and then what your product is. And so when you go and start working on something, or like how a website should behave, you can sort of say like, oh, how does Daniel, this imaginary person who has these characteristics, why would they come to this site? What would they do? And it's because like you have defined this imaginary person that you can actually talk through. And you don't have to represent every single person, because we all know that if you try to make everyone happy, no one is happy. So it's also a good way to just focus like who you actually care about, or who your actual target is geared towards. And so we can use this persona methodology in education and create like what's known as a learner persona. And this is great because, again, you're minimizing discrepancies about who you think your learners are, like who is going to use this set of materials, by making everything really explicit. And then that way you can just completely stay focused on the users. And in our case, the users are going to be learners, and the product is going to be the actual lesson materials. And so when you're going through this process, there's always this potential that you're going to create a wrong persona, but it's fine. Your personas are always a work in progress. But at least when you go through this process of creating a persona, it's still backed by data. So it's like, it's still true in some sense. And even if you create the product around the wrong persona, at least the product itself, or in our case, our learning materials, is still consistent for one person that we thought was the right person. So it's consistency. So we're not really like, oh, like I'm going to teach an intro course and I'm going to teach like, how to load up data sets. And then all of a sudden we're going to, sort of jump into Shiny, right? And it's like, okay, is that really like the reason why we're doing this? Or so it kind of keeps everything a lot more consistent, because in our case, it's really for people who are really new to this field, of trying to teach them like good data practices, and then also kind of nudge them towards a programming language like R or Python for their work. And so like something like Shiny could be out of scope, depending on how you define who your actual main target audience is. And so how do I go about creating these learner personas? We do them with a survey. And so yes, there's problems with doing things with a survey, but this is sort of like the best that we have. So there are 33 questions in the survey. We used 23 of the 33 questions to identify learner personas using like a clustering method. And again, this stuff was done across 2 years, which also included like COVID. So it's 67 people total over the 2 summers where like the survey was like conducted. And what I have listed in numbers are the general overall concepts that the initial survey had, and the ones with stars are the ones that were actually used for clustering to identify personas. And so just who are the people that took the survey? So the survey was given out to a bunch of people who are subscribed to like some kind of biomedically related like listserv. And so on the left, those are like the actual self-reported, and like I also gave them a bunch of options of like what their occupation was, and then I grouped those together into like 3 groups that was clinician, student, and researcher. And so if we look at overall how people responded to one of the questions, which was this Likert scale grid, parts that light up is towards the bottom here, you see like it's a question that says, I believe having access to original raw data is important to repeat analysis. And a lot of people say, yes, I really agree with that statement. But then if we look at some of the other stuff, which says I can write small programs or scripts to automate to address my problem at work, or I am confident in my ability to use programming software to work with my data, it's primarily like, no, they don't think they can do that. And then over here, you sort of see this bimodal distribution where like some people are indifferent and some people strongly agree with the statements that using programming languages like R or Python can make it easier to reproduce or work with their data. So there's some general sense of like what's going on. And then this bimodal distribution when I'm actually asking you about like, can you use R or Python? That sort of is pretty common to a lot of workshops that you teach where people are like brand new and then people who have done this before and sort of shouldn't be here. And so we sort of see that a lot in a lot of our courses. So I have this survey, and then now the question is, okay, I am trying to use this survey to cluster and identify people, but I still need to figure out if this is even a good survey to use. And so the way you can sort of work around like, is this a good survey to use? Like, is this survey actually asking the questions I like intend, or answering the questions I'm intending to capture? There is a method for that called exploratory factor analysis, which is one of the first steps on like validating a survey. And so of the 23 questions, they're known as items, and the 67 people, the first problem is I roughly need about 10 responses per item to sort of do this properly. So that would mean that I would really need like at least 230 people to respond to this survey to like do every single question, but I only have 67. So now the problem is, okay, how do we reduce the number of questions? So it's not 230, but at the same time, like 67, which means really 6 is not really enough questions. So I did go through some heuristic of like, okay, let's think of like a metric that is like, how do we know a question is like significant in the survey that I had? And so what I did was I looked at whether or not the question was correlated with other questions. So that is this row greater than 0.5. And so if that's correlated, that's a good sign. And then also, is that a significant correlation? So that is the p less than 0.05. And then from there, if 20% of the questions met both of these criteria, I pulled it into like the rest of the analysis. And so at the end of that, there were like 14 questions that sort of passed that heuristic. And we sort of went from there to see if this was a good survey. And then from there, we can actually take those 14 questions and then run what's known as exploratory factor analysis. So this is using the psych package using the FA function to do the actual exploratory factor analysis. And if people really want, I can show you the code for it, or it's like sort of linked down here at the bottom. And what that will do is sort of like group the questions together. And so what we ended up finding was that the questions actually group together into 3 general groups, and it's your responsibility as the researcher to see um, of these questions, so these 3 groups, what is it actually measuring? So now it's like, okay, there's principal axis 1, 2, and 3. PA1 contains all of these questions. So like you literally go back into your survey, read those questions, and then see like, okay, of all of these questions, what is it actually measuring? Because I could have asked the question thinking about one thing, but like these things are related to one another. So like, what is this set of questions, like what are their themes? And so the 3 themes that I sort of came up with was there was a theme around programming experience, a theme around programming for data analysis. So that's sort of just different from like programming for computer science related tasks. And then there's this other theme about like your ability to solve like a technical problem in general. And so those were the 3 themes that came out of this survey. And what's really nice about that is now that I have these 3 themes, you could potentially, instead of asking like all 23 questions, pick like the one that loaded the highest and sort of use that as like a representative question for that group. So this is also useful if you're trying to run your own workshop and you just want to get a quick glance of who your learners are. You can essentially just ask them these 3 questions instead of like, here's this whole like 33 question survey. So that's sort of like the nice thing that comes out of it. And then there's this other thing called Cronbach's Alpha, which I use the alpha function in the psych package, which essentially is saying that like, hey, of all of these questions in this group, like, are they like consistent? Like, are they like essentially measuring the same thing? It's not the best way you can do it, but it is one way. And so that's sort of the academic way of sort of showing those results. And then from there, you can use the hclust function that's built into base R to sort of take those results and cluster them. And there's this function called Hcut that will essentially say like, hey, where do you want the cuts into this dendrogram? And so if we really look at this, the actual best split of this data is 2 groups. And you can visually see it by saying like, okay, there's these 2 really long vertical lines right here. And so that's your visual cue that's saying that this actually is a 2-group split. And if we look at the questions, like it's not really useful because this group here like are all the experts and these are all of the non-experts. So that's the really simple like bimodal distribution we always see. So it's like that's not really a useful split. So then we went to the next group, which is group 3. And then we sort of found some differences that was worth explaining with doing this work. And so on the left, I sort of had that same demographics plot grouped up by the student, researcher, and clinicians. And then we sort of looked at those representative questions from the factor analysis. So one of them was question 3.4, which asked, how often do you currently use programming languages like R or Python, or et cetera, et cetera? And so here is the sort of colored bar graph of the 3 groups. And you can see like, okay, the thing that sort of stands out the most is there's green, which seems to be the more experienced group of the bunch. And then group 1 and 3 are like these never programmers. And if we look at how those groupings map onto the demographics, you can see like most of the green, if we just look at the green, they're students, and some of them are researchers. And if we look at just the blue, where the blue lights up, they're researchers and clinicians. So that is sort of like one hint of like where the grouping is going. But we keep going. So the next question in our factor analysis was question 2.7.7, which was part of that big Likert table. And this question asks, using a programming language like R or Python can make my analysis easier to reproduce. And you can see, again, the green bar is sort of showing up the most here. And then you have like the red that's sort of indifferent. And then if we look at the people that strongly disagree, it's only the red and blue. And so we can sort of map that out to the actual demographics where, okay, greens are probably students. The reds are kind of like researchers, and some students are maybe doing research, so they kind of fit into that role, or maybe they're brand new students. So that's sort of the sense that we're getting there. And then again, like if we just look at the clinician group, that's where like the blue bar is the highest. And so that's sort of giving a hint of like how this stuff is stacking up. The next question was, given a data set and you were asked to do some preliminary analysis, which of the following is like, would you be able to do an analysis even if you were given an Excel file? And the thing here that sort of stands out is like, okay, the people that have no idea where to start is group 3, and the group 2 doesn't really start making a count until like they're actually more experienced or able to do this type of work. And if we, again, compare it to the actual demographics, it's sort of building a stronger and stronger case for like, how am I going to group this stuff together? And there was another question about like, essentially the gist is like, are you able to run a logistic regression? Like, can you realize that like when I'm talking about a binary outcome, that the answer I'm looking for is like, run a logistic regression. Can you do that? And then again, group 3 is the group that like just has no idea where to start. And then the last thing that's sort of interesting was, even if I ask, like Excel is like prolific in just anything data related. But even if you ask like, how well do you actually know Excel? Like most people don't really know Excel either. So like we use Excel, but we're also like not very good at it, myself included. Like I think this is like 1 or 2 people that actually know what like a VLOOKUP is or an HLOOKUP is, or in Excel, which kind of makes sense because not that many people get that far in their Excel careers. And so that's sort of like interesting too, because like we use this tool like Excel, but we're also like not very good at it. It's just a general finding that I thought was interesting. All right, so then with that, you take those findings and those group values and you sort of give them a name. And so like the names that I sort of gave it was like, okay, we have this one group that were students, there's this other group that's academic, and then this other group that's clinicians. And that actually is kind of nice that sort of like split itself out into the data that way, because that was like what my dissertation was based on. So it was kind of nice seeing that happen. But it's also nice that there was a process that you can use to like see if this works for your learners or whatever use case that you're trying to go. And you can sort of generalize that even more. So like you can have these personas and you can give them a name. So I have Ash Academic, Samir Student, and Claire Clinician. And you can sort of give a general table about how they're responding to this, right? And when I first gave this presentation to my actual like dissertation committee, I essentially said like Ash Academic has like medium statistics knowledge, and like one of my community members was like literally the chair of the stats department. I'm like literally telling him like, yeah, you're an academic and you're not very good at stats. But like that's not really what I was trying to say, other than like probably if you're an academic, you also have to think about like where this data is coming from. The people who took this survey aren't actual like chairs of the stats department. This came from a call that was saying that, hey, someone's trying to run a data science class. Like, do you want to attend? And so like that's the incoming group of population that's coming in. So like even though I say academic, they're not really all academics. These are probably the people who just graduated doing research that want to learn a new skill. And so that's the sort of like thing you have to keep in mind of like who are the people actually taking the survey. And then so with that set of information, you can create an actual learner persona, and it looks something like this, where we have Claire Clinician. They have 4 components to a persona, and this is modeled off of the RStudio learner personas, where you have a background, which is sort of just made up just to make sure it sounds like an actual person. But the relevant prior experience and perception of needs, that comes from like some of the survey data and some of the free response questions. And then the other thing to keep in mind is even if it doesn't come up as a survey response, you do want a section where you can put in special considerations. So what does it mean when like you are a single parent who has to juggle their work and trying to learn a new skill? Like that does feed into how you're going to structure some of your lesson materials, because that also means that you can't just rely on the fact that this is going to take like 5 hours a day to teach. So you have to like sort of build in some mechanism, at least for Claire, that like they can maybe do something a little bits and pieces every day, but they're not going to be able to spend large swaths of time to go through and learn this stuff. And so, yeah, this was really step 1, which is saying that like, yes, you can do a backwards design. You can create learner personas. You can actually create a survey and then use the survey results to actually group them together to create personas. And so that was like the proof of concept that you can actually do this for real. So the next step is, so you identified your learners, the rest is like, yeah, like go draw the rest of the owl, right? Like now go do the rest. So you have to go and plan out the lesson content, knowing that you have this persona, all these personas set up. So how do we go about creating the learning materials? First things first, identify who your learners are. And so on the left hand here, this is an example of a concept map. And there are other ways to break down a problem that you want to teach. One is using concept maps. The other one is a process called task deconstruction. And concept maps are essentially, each node represents like a unit of information, and then each edge is how those units of information or knowledge are connected to one another. And essentially how this is good for a teacher, because this is how you can sort of plan out and say, I need to teach all of these things and sort of tell a story about how all of this is connected so my learners can learn something. It's also useful because you can see here in these dotted boxes is how you can sort of say like this box here is what I can teach today. And then this other box here is what I can teach tomorrow. Or if you run out of time, you know where you can cut information. And so it's also useful in some sense for the, it's one tool that you can use. It's not the only tool that you can use to plan out a lesson curriculum. And then essentially how many nodes you have and how dense your connections between nodes are in your concept map sort of can show you like how much of an expert you are. So like there's this other thing known as the Dreyfus model of skill acquisition that is sort of this transition from novice to expert. And essentially the density and connections that you make in your concept map relates to how well or how much of an expert you know. And this is important because novices don't have a lot of connections. Competent practitioners do. And an expert has a lot of like jumps in their connections. And so that's why, at least in the carpentries, we sort of teach our new instructors about this expert awareness gap. Because for an expert, it's really easy to go from like, oh, point A is really connected to point F, and we can make that jump immediately. But there's no way a student who's never seen this before can make that jump. And so like what might seem really easy for an expert ends up being like this really weird mental jump for novices, and this is why. And that's why it's actually sometimes better that like the actual experts don't teach unless they are taught how to teach and learn about their own awareness gaps. Because if you're trying to teach novices, you're going to end up making a whole bunch of mental leaps that will actually make no sense to novices. And that's something you have to be very mindful of. And so now that we can kind of plan out what bits of knowledge we want to teach, so we're going to end up using a summative assessment. So like this is the final exam. At the end of like this set of learning materials, I want you to be able to do this. And what this is given the data set at the top, I want you to create the data set on the bottom and then run an analysis of it. And you have to, the first thing I want you to recognize is that there is a pivot, which one is this? A pivot longer step that exists in here. And so the code on the right is, I want you to be able to load an Excel data set, filter some data, write some data out, because that cycle there is the beginning of creating data pipelines. And then I want you to be able to understand that like, hey, there's a data transformation step in here because that is really important to do your plot and your model fit. And so those are the 6 steps that I really want you to be able to do. And that's the code that will hopefully by the end of the learning materials, you're able to do. And then you can also do the same. I also want you to be able to do the same thing in Python. Well, not you, the learner, but like I want the materials to be general enough that you can also do this in Python. And this actually translates one-to-one pretty well. So once you kind of build out the set of materials, the next question is, okay, I have all of these learning materials. How do I know that this is like a good set of learning materials, right? Like in education, the word effective is like, okay, I want to know if this is effective, but that's super vague. Like, what do you mean by effective? So how do we go about and test that? So again, there's a set of surveys. What we do is people sign up for a workshop. We sort of give them a survey before the workshop starts, after the workshop starts, and then sometime after 4 months, we give them another survey to see how much they retained. And the main thing I want to keep in mind, at least for these results, is these are all self-reported ability. So like I'm asking you, what is your confidence in being able to perform that task I just showed you? I'm not actually grading your code or grading anything. So things are probably going to be inflated because you're going to say like, oh yeah, I think I know how to load a Excel data set, even though you probably forgot all of the syntax. But so that's something that could happen. So how do we go about planning out the effectiveness? So there is this thing called Bloom's taxonomy. It's usually presented in this pyramid. And what's nice about one of the things that's nice about Bloom's taxonomy, there are problems because it's presented like a pyramid, is that for each one of these levels of what you're trying to convey, you can use like a set of like actual action verbs. So like, I want you to be able to define what tidy data is, right? Can you define it? And that is like a thing that you can go and measure. Like, did this person define it correctly? Or like in the apply level, there's something like execute or implement. Like, can you implement like the function to like square number or something? Like, I can actually go and test you on that. And so that's where Bloom's taxonomy is sort of useful. This pyramid that you see is you'll see it everywhere, and you shouldn't really use this pyramid, even though I've had publications that use it. There's this other pyramid or this other diagram for Bloom's taxonomy that essentially says like knowledge is the base for everything. And if you can teach something some base of knowledge, you can then go into the analysis, you can then go apply, and then you can go teach another bit of knowledge and then jump around to different aspects. And that point isn't really conveyed in a pyramid because like I'm not going to teach you everything in isolation and then hope you understand. And then once you understand, you go apply. Like there's cycles in your learning process that doesn't get conveyed when you have a pyramid. And so using those learning objectives from Bloom's taxonomy, you can have all of these learning objectives. I want you to be able to name features of a tidy and clean data set, transform data for analysis, identify, assess, break down, construct, calculate, interpret, communicate. Those are all the actual action verbs that if I were to write a university class from scratch, like I can write a test around those verbs. And so what I ended up doing is writing the learning materials, and it's hosted at this website here. The things that were used for the workshop or for this study are the first 8 chapters of just introductions. I actually just spend like the first hour just on like spreadsheets and good spreadsheet behavior, because the main thing was like, even if you just leave this workshop or this class, like just know how to work in Excel. That was sort of like the goal there. And then if you want, you can also then apply some of this stuff into a programming language. And then from there, after like loading data and some like example of what you can do with data, like the first thing I try to teach is just this concept of tidy data, because it really is like the fundamental part to like do everything else. Like if your data is not tidy, you can't visualize it, you can't run a model, you can't really do anything. And so that's sort of like why tidy data was sort of put as early as I can. And then what I ended up doing was sort of expanding out the materials. This wasn't really tested, but it was this was taught, but it wasn't part of the analysis of, okay, so I have all of this medical data and all of these people who work in the medical or health industry. Let's see, like if I can come up with a curriculum for like part 2 for like more advanced uses. And it worked out pretty well, but then the question is like, as soon as you get into like more intermediate topics, like anything can happen, right? Like some people really want to work with maps and census data, and some people don't. And so now it becomes actually really hard to like make domain specific intermediate materials. And it's a little bit easier to figure out like where the foundations are. And then sort of anyone can write like intermediate materials because that's going to be even more specific. And the topics that are like fundamental are essentially like almost endless. So it becomes really hard to plan out like, what would a part 3 look like? Well, it gets a little harder because like I'm not very good with maps, for example, but like some people really want maps. So how do we go? And so we have the learning materials. Now let's go actually measure the efficacy, if I spelled the word correctly. And this is the, when we sort of talked about this before the recording went on, I talked about like education research being very difficult and underpowered because of response rates. And so I ran 8 workshops over the 2 years. There were 200 people or 200 attendees across 2 days. I think there was like 170 unique people. And there were a total of 91 responses of the 200 or 170 people who took the workshop, 67 took the pre-workshop, 47 took the post, 11 took the long-term. And if you really look at the center here, only 2 people took all 3. And so originally it was, okay, I want to be able to track everyone across time. And, it would be really good to have an analysis that said, this is someone who went in before the workshop, after the workshop, and long-term and track them through. But I only have 2 people, so I can't do that analysis anymore. And so what I ended up doing was essentially throwing out all of the overlaps here. So I only looked at the 39, 16, and 8. And that is because I essentially treated this as like a series of like time points, snapshots in time, instead of trying to track individual people, because those are 2 different types of analyses that you would do. And if I had more people, I might be able to do more with that. But this is sort of just where I was. This is like all I got. So that's where we were. So I'll go past that slide and go to this one. And this is essentially saying like, how are people responding pre and post workshop? And essentially the more, so the blue is pre and the red is post. And essentially of the 2 sets of questions, most people are on the stronger agreeing to being able to do something after the workshop. So that's kind of good. That's like a good litmus paper test saying that like I wasn't terrible at what I was doing and people actually learned something, or at least they felt that they learned something. And so that's sort of like a good expected baseline. What I then ended up doing was part of the post and long-term assessment was I actually showed them those 2 data frames and said, like, given this set of these input and output data frames, can you load a data set, filter data, save it out, tidy it, plot it, and fit a model? So I actually asked them, how did they feel about performing those 6 tasks? And so blue is post and red is long. It's kind of hard to discern what's going on, but essentially like there's a wider band in the long-term workshops compared to the post-workshop findings. So that's really the only thing I can really say about this is like more differences in the long-term results. And if we really compare like pre, post, and long, so like the 38, 16, and 8 groups of people, from blue is pre, green is post, and red is long, essentially it follows like this weird like V-shaped curve where like blue and then it goes up and then kind of goes down is sort of like the general trend that I'm trying to like hint at. But this set of results is a little bit difficult to look at if I'm just looking at the raw like Likert scale results. And so what I ended up doing is making a composite score, summing up the Likert scale, and then comparing all of them together. And this sort of illustrates the point a little bit better, which you have some baseline pre-workshop condition. You have a post-workshop like improvement. And then like 4 months later, or some of these people answered the survey like 8 months or 6 to 8 months later, it dropped back down almost to the point of like before the workshop. And so this is sort of like hinting at like, okay, like workshops help, or at least like people feel like they help. But then if you don't really like use the tool or anything, and you're just attending the workshop for like, oh, I want to go learn something, you're just going to forget everything, essentially, is what I'm trying to convey that point here. And so really what should happen when we as educators is trying to have a system where we're trying to have our learners like engaged long-term. And so like stuff like, you know, RLadies is like a community where like you can have continuing education and like maybe, I mean, not all of your talks are like just, you know, not code related. And some of your talks are like about R and how to do something in R. And so like that sort of is like a little nudge, like, okay, are you kind of forgetting how like tidyverse works? Well, there's this talk like next month, and it sort of like remembers or refreshes your memory a little bit. And so that's a way you can keep engagement and sort of retain skills over long term, because maybe, you know, all you're doing is like making maps all day and you're not really cleaning data. So you're probably going to forget like some of the dplyr functions. That happens to me constantly, where I never know how to make a map. And I feel like I'm learning how to make a map every time I have to go make a map, like from scratch, because I never use it. So like, yeah, that's anecdotal evidence. And this is sort of like a really underpowered study that sort of shows the same sets of results. So yeah, you can use learner personas to sort of gauge content. What's also nice is because I focused writing the set of materials in both R and Python, I can really think about like what's actually fundamental in terms of working with data instead of like being super specific on like a specific package. So like there's stuff like I didn't really teach like the janitor library in R because even though it kind of does exist in Python, like, it doesn't exist in Julia, for example. And so the more you can think about like teaching something across multiple languages, like the better it is to figuring out like what is actually like a fundamental concept that you need people to learn. The other thing is computer science and data science learning paths are very different. If you've ever taken an introductory R course and all of a sudden it's like, okay, we're going to learn about if statements and else statements and then for loops. And then you're like, well, I don't really use any of that when you're processing data. Like you literally just load data and you have a data frame, and then you're not really writing for loops as much or if statements until you get to maybe functions. But like I didn't even cover functions in the first like half of the lessons because it's not really that fundamental in thinking about processing data. It's like that is a super specific thing that you need to learn when you have like a really specific problem, but it's not a fundamental introductory skill. And then long-term practice is important. Having examples that are really domain specific can sort of help with keeping you engaged. And then the communities of practice or other learning environments can help, sustain your learning over time. And so what are your practical implications? If I was teaching this to like a set of clinicians, you can actually start your own study, right? Like you have lowered the barrier and you can sort of work with data on your own before you start talking to a statistician, or you can get like, I can sort of do basic plots and some basic analysis before I need something more complicated, which I kind of then would need to talk to a biostatistician. But then I can also have a more informed conversation because I've also kind of analyzed my data a little bit, so I know what's in here versus just, hey, person statistician, like here's my data, like can you tell me anything about it because I can't do anything. So that's really what's really useful with having a really specific domain and specific people, because they should be able to relate to that, their processes a little bit easier. And then in medicine, like there's also this thing about continuing education. So this also does plant the grounds that like you can have continuing education topics around like data science that people can take CE credit for, to sort of re-up their credentials. And then so if you're an educator, you can also design your own materials. So you can take the process that I've used and sort of do that with your own potential set of learners, or you can literally take the surveys that I've written, which is posted somewhere on my GitHub, and you can use those surveys to like sort of ask those surveys, maybe tweak them for like if you're a lawyer, you can tweak them for like a law related example and go on from there. Or you can take those like 3 representative questions that I have factored out and sort of use that as like, hey, we're teaching a workshop. Like, can you, before you take this workshop or sign up, like, can you answer these 3 questions? And then you'll have a general sense of like who's attending your workshops or who's signing up. And then if you notice that there's something bimodal going on, you can actually say like, hey, like there's actually this whole class of people who are experts. Maybe we either one need to tell them, no, the class is out of scope for them, or you move them all into a separate cohort. So like the actual novices are together and you don't have a room of like, computer science experts who wrote the programming language like in the same room as people who are trying to learn this and do this for the first time, because that's also really disruptive. And then the other thing that I've worked on, I didn't really talk about, but there's also like, as an instructor, there's like 3 different types of knowledge that you as an instructor like sort of have to know about. So there's one is called content knowledge, which is literally just what me as the instructor knows. There's curricular knowledge, which is what do I actually need to teach the content? So like the actual like learning materials that I'm using. And then there's also pedagogical content knowledge, which is like, how do I teach? And so I've sort of gone through the process of like the first 2. There wasn't really a process testing like how to teach. So I can say, at least for the research that I did all of the teaching. So if if people think I'm a bad instructor and that's the reason why like the results are skewed, at least they're consistently skewed throughout the study, right? So like I'm consistently bad in your eyes, and so that's fine. There's consistency there in the results, but that is something that also does matter a lot with education research. Is who's teaching this, and then can they teach, or is another question, which is why education studies also become really difficult, because if it's really one person teaching the same thing, to keep some kind of consistency, then it's like, yeah, I taught 8 workshops over the course of like, it was really like a year, even though the whole study took 2 years. That does take a lot of time to do that, and also consolidate and set up all of the courses and stuff. So we're almost at time, but the overall conclusions, essentially the pre, post, long term, the really important thing again is to think about long-term practice, and that sort of goes along like the popular psychology set of literature, which is like, the Malcolm Gladwell's like 10,000 hour rule. There's the Lazo and Clara's deliberate practice, and then there's also this notion of like a forgetting curve, and that all plays along into like the long-term practice and long-term retainment of knowledge. And so really, we should really all just think about writing exercises and thinking about how to retain and keep people engaged over a long period of time. And that's where, if you as an instructor can't do this, then you have communities of practice that can help you. So like the carpentries, there's like literally Slack groups that are really specific to medicine. Even stuff like Tidy Tuesday, Nishal, who I got to recently work with at our studio, he wrote a paper that actually shows that like Tidy Tuesday actually is its own online community of practice. And so if you want data sets to practice all of these data skills, like Tidy Tuesday, actually proven by research, or shown by research, not proven, is actually really useful. And having like study groups around Tidy Tuesday is also like a pretty low effort way of just getting people together to work on a data set. And that's what we do on Twitch. Like people just Twitch stream like their Tidy Tuesday stuff, and we all learn together. I can learn and see how people think about problems and struggle through problems. Like there are people here watching me right now who have seen my streams, and they can totally attest to the fact that, yeah, I can't really do this off the top of my head, like as what most people might think. But the same thing, like RLadies and PyLadies and the R4DS community, like all of these other Slack groups and all of these other groups, there are mechanisms where you can keep engaged with the materials to sustain long-term engagement. So just hearing and remembering about these, or just getting you to think about something in some kind of repetitive process is enough to like essentially stop you from forgetting it entirely. And so like all of these other groups are ways of sort of just like, hey, like maybe we like, as like RLadies like planners, like maybe you have this question like, hey, we haven't had a geospatial talk in a long time. Let's go find someone who can give a geospatial talk. And then you sort of re-up the whole forgetting curve for the community, right? So it's pretty rare where you'll have like, hey, let's just have the same, not the same person, but let's have a talk about like the dplyr library 6 months in a row. That's probably something that doesn't really happen. So yeah, exactly. Like geospatial knowledge is like really hard to find. And that's also the reason why I have to like relearn it by myself every single time, because like I don't work in it. So like I just forget it. And then stuff like that. And then there's also like really specific medical groups. So like Odyssey and is one of those groups that actually work with like patient health data, and they're an open community around that stuff as well. And then last but not least, as an instructor and something that I've learned over the years, so this was a list that was compiled by Greg Wilson about like all the rules that you should think about while you're teaching. And I'll sort of just leave this up here for people to read, but I really do think that rule number 1 is probably the more important one out of all of them. So I think that is it. Yes, I will leave.
Thank you so much, Daniel. Virtual round of applause for such a great talk. There's so many things that I'm like, oh, I totally relate to this when I was like starting to learn R and was like struggling by myself and trying to like figure out, I don't know, just how to write a function or just try to do some simple things. And I wish I kind of like had these um, these tips that you had here and was able to apply that earlier rather than struggle for the beginning, like after just taking one workshop. So thank you so much for this. I see that Lisa, you have your hand up. You have a question?
Yeah, I was wondering if Daniel, you're open to taking some questions. I do have a couple, and I'd love to hear your thoughts. Thank you so much for this really good talk. I think you really found a good balance between technicalities and accessibility. So fantastic job on that. Yeah, I have two kind of big questions, but I'll start with the first. So you had mentioned a lot of personas and really trying to figure out what is essentially like the beginners and intro, what is oftentimes undergrad level. And as you kind of get into the more intermediate, levels of teaching, and like as you're trying to kind of subset a lot of these more like intermediate analyses, such as survival, you might kind of not necessarily have as many students where you can kind of group and actually create personas off of, if that makes sense, based on just like the limited availability. And so in turn, I noticed that there's kind of this oversaturation sometimes of intro materials that are very good at teaching to these specific personas. But once you get into kind of the more harder intermediary stuff, we kind of lose sight of who we're teaching to. And you also have like this other problem of maybe only experts are kind of able to teach that material too. And as you mentioned, they might not necessarily be the best equipped to. So I was wondering, in your opinion, what is the best solution to having effective intermediary teaching, just with all of this in mind?
So I'm gonna try to rephrase that as a question, which is around what is best ways to like go beyond like this oversaturation of like intro materials. So this slide that I just pulled up, I hope I'm still sharing. I think I'm still sharing. So one of the things that like why is this the set of materials that I picked and not like something else? It's like another way I can kind of rephrase that question, because this is the one I know how to answer. So so the first task was like, okay, I'm teaching people who work in, or ideally like clinicians and people who work in hospitals. And so in general, I didn't pick a specific department, but in general, hospitals have this question of like 30-day readmittance, which is, given that you come into the hospital ER for a heart attack, do you come? Oh, this applies in the United States. I have no idea how the health system in Canada works. I'm assuming much better. But given that you come into the ER with a heart attack, do you come back 30 days after you get released? And the reason why that's an important question, at least in the United States, is because insurance companies won't reimburse hospitals if they come back within 30 days. And so that becomes a huge question. And it's a balance for the hospital of like, do I let you take up a room in the hospital, like take a bed, or do I like release you early and then hope that you don't come back in 30 days? And if you do come back, like hopefully it's 31 days, so then we get reimbursed, right? So that's a question that every hospital has. And that's sort of like where I focused a lot of the next set of questions, was because that's a big question people have. So like I go through 30-day readmittance, which actually, funny enough, is really just a recap of all of part one, because you can answer this question with very basic dplyr skills of like filter and group by. With multiple data sets, that still ties in, which is, okay, I can figure out who like the patient number is, but then I have this other table of like their demographics, like the patient's data set, and not just the encounters data set. And so now I can talk about joins, and then with joins, then it's okay, now I want to know about comparing this to like the local census. So that's where APIs come in, and then APIs require functions, and then now it's like survival analysis because I want you to see if you come back in 30 days or not. And then the last one was just sort of a bit about machine learning intro because I got feedback around it. So the answer to your question is part 2, the way I have it framed, is actually one giant project. It's like one very big multi-tier question that if you were a data scientist, you probably will end up touching on all of those skills. And so when you're thinking about more intermediate things to learn, I think it's okay to say like, I am going to be the person that tries to train how to do 30-day remittance, and I write a curriculum around this one giant topic. And then using that one giant topic, you try to cover as much material as you can versus like, yeah, I'm going to teach maps, and then I'm going to teach like spatial statistics, and then I'm going to teach all of that. Like, it's okay to say like, no, we're just going to do this stuff because chances are it's already enough. Especially in a workshop context. Like if you're writing like a book, maybe that's a little bit different. Or like if you're trying to write like, you know, even if you're writing a book, your book still has like an audience, and that's sort of where the persona thing comes into play. So yeah, like for part 2, I sort of did a very rough outlining of like, yes, I want to write a whole set of courses around 30-day remittance. And then I have a background in public health and epidemiology. And so like I also just borrowed off of that of like, hey, most people who do health research talk to a biostatistician. This is what we learned when I was in public health school, which was like logistic regression and survival analysis were like the tools that we pretty much saw over and over and over again. So that's sort of why I gravitated towards that set of materials. And if you're like an introductory learner, or if you're just transitioning from like very beginning to intermediate, chances are you haven't seen any of that stuff anyway. So it's like going to be new and novel. And then you sort of listen to what your students have to say to sort of say like, what else do I need to teach? So like this machine learning intro, which is like me trying to condense like how to teach tidy models in like an hour and a half, stem from the fact that like I got a whole bunch of feedback saying that like I thought we were going to do like actual machine learning. I was like, okay, fine, I'll like put it in.
Awesome, thank you so much. That was a really in-depth answer, and so I really appreciate it. I do have one other question. It won't be as like big. Oh, maybe it might be bigger, but we'll see. If you're willing to answer it, of course. So I noticed that in data science, particularly at UBC, which is your institution, there is a lot of dedicated just curriculum instructors, and that is a really cool thing to kind of have branch off. Do you see that as also being a larger trend in other departments, and how that might, change in, academia in general? Because typically we're like, okay, this person is top of their field, let's have them teach top students. And then we realize like, hey, maybe they're not the most effective at teaching after all. And so we're hitting this new trend, right, where we have dedicated instructors, but it's something that I see mostly just in data science, and which is awesome considering how new data science is. Yeah.
Yeah, so part of that answer is like that's the reason why I'm in Vancouver. And like so the other like kind of fun background story is like I drove from New York City to Vancouver, like, and it's like there's very few things that would cause me to do that. And so like UBC is one of those very few schools that in the stats department, like my actual position is like literally just teaching. And it is like a trend in the sense that like you can probably count with one hand the number of universities that have like tenure track positions that are teaching only. And so that's sort of nice that it exists, and hopefully it expands further. The other thing is there's always ways like universities like I've started to like think about like why doesn't this happen like across every single department, and like at the end of the day like funding does become an issue. So like because data science and departments related to data science get so many students and funding, they can probably afford to have people who only do teaching, versus like other departments who also have to kind of rely on like paying their instructors through grants, they're not able to do that for like financial reasons. But like, yes, in an ideal world, you find people who know how to teach, and not just experts who just know a topic in their field. Or you end up like in a situation where like you spend a lot more time and effort teaching the experts on how to teach, but then you sort of end up in this weird like thing where like people's egos are involved, because it's like, I'm the expert in this, why do I need to know how to teach about this because I'm the expert? And then you kind of like, they have to like sort of put down that hubris a little bit, and there's be like, yes, there's this whole thing about like expert awareness gap that like you should be very mindful of. And so yeah, like when I was in undergrad, I just thought like neuroscience papers were really like complicated, and it just turns out that like, no, just people don't know how to explain this stuff. So you see that a lot in academia. And so that's at least I also know like in the United States, like to teach K-12, you actually have to have like a teaching degree, or like you get exempt from it in some way, shape, or form. And then like at the university level, it's like all like, yeah, okay, fine, you can get a grant, we'll let you teach. So so yeah, there's like, at least the university level, it is weird, and there are like weird incentives. But having at least a few universities that have teaching only tenure track positions is a good way forward.
Awesome. Thank you so much for answering that. That was a great answer. Perhaps the issue of hubris is maybe beyond the scope of your postdoc, but I do hope one day you'll find a way to address it. If anybody else has any other questions, please feel free to unmute or post in the chat. I'm sure Daniel would be happy to answer either regarding this talk or his career or R in general, although I wouldn't get him to debug your work. Like, maybe his Twitch is better for that.
Yeah, Twitch debugging is always the best.
Yes, maybe you can plug, or are you planning to have another Twitch stream soon?
I have no idea when it is gonna be.
Okay.
It might be sometime this weekend, but it might be like, so I need to condense this talk down to 20 minutes. So that's probably what this weekend's gonna be.
Nice.
But yeah, I used to do this thing on Twitch where like I would do Tidy Tuesday, and I would time block, get as far as I can doing the R stuff in like 45 minutes to an hour, and then spend the other hour doing it again in Python. And part of it was just like, this is like sort of the thing about like deliberate practice, where like I kind of know Python, but I want to actually force myself to use Reticulate and see how Python interacts with RStudio. And so that's the other thing, like learning about how to teach can really help you as a student or learner, because now you sort of know how to learn. And so for me now, it's like, okay, it's easier for me to pick up a new skill because I actually kind of know, like going in as I'm reading something, like what I need to do or need to focus on to learn something. And so, yeah, so even if you're very new and this, if this, for example, is like the very first RLadies talk that you've ever been to, just know that like the next talk you go into, like if you have some idea of what you might be able to take out of it, or like listen for certain things that you want to be able to do, one, it'll keep you more engaged, so you're more focused, and that'll all help with learning. But then like you're able to focus on something and not just get overwhelmed with like all of this brand new information. And so like for me, when I was first learning data science, it was like, okay, what is like train test split? And then after like the first 15 meetup talks were like, I've heard it enough. It's like, okay, this makes sense now. And now like when I listen to other machine learning talks, it's like, okay, I just need to know if they're using the same type of train test split that I understand, or they're doing something different. And then I can sort of like focus on the new bit versus like the thing that I've like kind of already learned. So like going into a lot of these things, like proactively learning is really like a skill that like I hope people who are very new to this like try to do.
Yeah. And that's like a really good tip to do, like half Tabby Tuesday in R and half of it in Python, because I feel like I started out learning Python and now I'm like fully in R, and it's been hard to try to like get back into it. So I feel like that's a great tip for anyone who's trying to master both. Um, yeah, I guess if there's no other questions, I'll throw out like one last question to round it off. Was wondering what's your favorite thing to teach after teaching so many workshops and
So I like teaching the tidy data stuff. I've gotten better at like using the words to explain what I mean or what it means. So I like teaching that stuff. And the other reason why I like teaching it, so it's hard to say, like, do I like teaching it because I teach it so often because I think it's really important, or do I actually like it? Like that sort of eventually gets like muddled together. So same reason, like, do I actually like teaching? It's like, I don't know. I've just been doing it for so long. I don't know if I like it or if it's just like a part of me now. But I enjoy teaching the tidy data stuff because, at least for me, when I first realized that's what actually is a tidy data set, and like all of the other things you can do pivoting tables around, like for example, you don't have to write a for loop to calculate the average for all of your columns. Like you can literally pivot table longer, do a group by, and then pivot things back. Like there are things that you can do if you sort of intuitively understand how pivoting table works that can sort of make your life easier. And having a tidy data set is essentially like the gateway to everything else. And so if you don't really understand how that works, like you can't actually do anything else with the language. And that's kind of useful too, because I learned how to code in Python for software programming, but I learned R for like data work. And the only reason why I sort of learned data analysis in Python was through tidy data transformations. Like that was translating all of that stuff into pandas was sort of like, oh, now I can do all of the scikit-learn stuff. Or now I know how to like load in a data set and do that. When I do go down my JavaScript learning like journey, I think that's essentially going to be the same thing that I'll do, where there's like a library called tidy.js. And so, yeah, load a data set in JavaScript and then tidy it and then work your way there from learning the other libraries. So that's also a reason why I like teaching tidy data, because at least my opinion is it is like the actual most important topic when you're working with data.
Very true. Well, if there are any last minute questions, feel free to unmute. Otherwise, I'll stop the recording now.